So this is the feedback for the progress check 8. If you could check your own work and look at where you made errors or where you didn't gain full marks and look at what you can do to improve. So this first question was a straight line question. You've been given the equation of a line, but it's not in the form that we would instantly recognise, where we can easily identify the gradient and the y-intercept. So the first bit of this, where it is asking you to come up with the gradient of the line, this is asking you to show that you understand that in order to be able to identify the gradient, you would need to rearrange that equation into the general form, which is y equals mx plus c. So it's a bit like using your skills for change the subject. So basically we're going to try and first of all isolate the term, the 6y. So I'm going to say we can do that. You can do this in 1 or 2 steps. We can first of all say, well, we're going to get rid of the 12 and add 12. So that might mean that you could then write that equation. You've got 3x plus 6y equals 12. So now you've got your x's and y's on the one side with a number on the other. But remember, it is just the y term that we want. So we need to then get rid of the x's, and we would do that by subtracting 3x from each side. And that would then allow me to write 6y equals, I could write 12 minus 3x, but I'm going to write it so I get it in the order with the x term first, then the constant, so I'm going to write minus 3x plus 12. Now, sometimes people think they've now arrived and they can write down what the gradient would be. However, the gradient, it needs to be just one y equals mx plus c. So at this point here, we now need to divide by 6, and we're going to divide each of the terms on this side by 6. So that means I would be doing this, so minus 3 over 6x, and we would have 12 over 6. So each of those terms getting divided, of course, by 6, and then from there you would simplify that and make sure that you wrote down y equals minus 2x, not minus 2x, minus a half. Don't make the mistake of thinking, oh, it's 6 and 3, so that's 2. Right, remember it's 3 over 6 that we're looking for here, so that should have simplified, right, to y equals negative a half x plus, right, that part is 2. So now at this point you want to be comparing the equation with the standard format, and that standard form being y equals mx plus c that we've already mentioned. Right, so you are now going to compare, right, to y equals mx plus c. So now we can see we've got it written as 1y equals something times x plus c, and the something times x is what your gradient value would be. So the gradient for this straight line would be negative a half. Now your marks for that question, you do get 1 mark for first of all starting to rearrange that equation and kind of getting down to this line here, and then the last mark is really for getting down to the 1y equals and identifying the gradients. That's how you'd earn your 2 marks there. The other part of this question was about identifying where the line crosses the y-axis, and remember that because the c value is equal to 2, so your y-intercept will be the point 0, 2. And it's important you don't just write down 2, you need to actually state the coordinates. Right, that's what the question said. The question said state the coordinates of the point where the line crosses the y-axis. So while we can easily, right, say from that number at the end, that's your y-intercept, you need to write it, list it as 0, 2, and that's how you would that in its own was worth 1 mark. Right, question 2 is a factorising question. There are 3 different types of factorising. You should always begin by checking for a common factor. So here we've got 5x squared minus 20. I'm hoping that you could spot there is a common factor there of 5. So we would take that outside, it would become 5 bracket x squared minus 4. Now, whenever you factorise with a common factor, you should always then check, can I split it up any further? And when you're splitting it up further, you're looking to check if you've got a difference of 2 squares, or the other type would be the trinomial. And that's kind of the order that you would go through for. So we've already seen that we had a common factor. Now when we look at this, we can see difference of 2 squared. The word difference means take away. You've got 2 square terms here. The x has clearly got a square on it. The 4, although it doesn't have a square on it, is in fact a square number. It's 2 squares. So in fact we've got difference of 2 squares going on here as well. So that does mean that that will factorise and split up further. So it would become 5 bracket, and the standard process for a term that's a difference of 2 squares is 2 brackets that are almost identical apart from the signs. Got the same terms, same first term, and your last terms, one's got a plus and the other one's got a minus, and that's it factorised. Now, to get the marks here, you would have 1 mark for doing the common factor, 1 mark for doing the splitting up into the difference of 2 squares. Right, question 3, bit of your statistics here. So you've got a list of temperatures and you're asked to calculate the median and the semi-interquartile range for these temperatures. Now the first thing that you have to do with this type of question is make sure that you have the numbers listed in order. So, and it's always a good idea when you're doing this, if you're doing it in an exam paper, sort of score them off, make sure you've not missed any out, and also make sure you've got the same number of terms that you in fact started with, so you can do that fairly quickly. So how do we work out the median and how do we get the semi-interquartile range? So the median, of course, is the middle. So here you will see we've got 2, 4, 6, 8, 9 numbers. So 9 numbers means that we do in fact have a middle number. So that middle number is our median. Right, so our Q2 is 6. So your median, right, which is the Q2 number, is equal to 6. Now to do the semi-interquartile range, you need to be working with the other quartile numbers that we're looking for, and that is Q1 and Q3. Now if you're looking at, when you take the median out, you've then got, it splits into 2 different data sets either side. So you're now looking at the middle term here. Clearly you've only got 4 numbers on this side, so there's no middle. So your middle would be in between that 4 and 5. So we would write down our Q1 value would be 4.5. On this side, you've got your 4 numbers again, so your middle here, which would be your Q3 value. Now, because they both match, it means that the Q3 value will in fact be the same. So what you'd be looking for here, right, and you weren't allowed to use a calculator to do this, and that you would know the formula. So the semi-interquartile range is the Q3 value, which in our case is 9, minus the Q1, 4.5, and then we are dividing by 2. So our working, right, should follow on from what we've just done, or what you've just worked out in terms. So even if you make mistakes with your Q1 and your Q3, if you're using the correct formula and you sub in here and you correctly work out even for your wrong numbers, you might still get a follow through mark. So 9 take away 4.5 is 4.5, and you're having to divide that by 2. So you would be doing 2 into 4.5, no calculator here. So 2 into 4 is clearly 2, 2 into 5 is 2. You've got a remainder of 1. Because this is decimal work, we need to add on a 0 into the end of that decimal number and carry the 1 over there, so that what you get is 2.25, and that's the value for the semi-interquartile range. It is 2.25. So, and you've got a mark for that 2.25. That would actually be the third mark in the question. So the first mark was for the median, and so that was the first mark. Our second mark is for both Q1 and Q3. That's how you get second mark. And then your third mark is for working out the semi-interquartile range. You should show the working here, even if you don't state the formula. You do need to know it, because it won't be given in the formula list. Right, number 4. So this is simultaneous equations. You've been given a pair of equations. So this is about looking for you to know the techniques that we would use for this type of thing and be able to solve them. So here, you're always, as always, expected to, I would say, number these equations. So we're going to call that equation 1, equation 2. And we're looking for how we can eliminate either the A or the B, because an equation with 2 letters in it's difficult to work. You can't work out a unique solution from that. But 2 pairs of equations with 2 unknowns we can, but we do that, the process is to get rid of one of the letters. So in order to do that, we need to make the numbers in front of either the A or the B to be the same. So there are 2 methods for this. I'm going to focus on getting the numbers in front of the B the same. Because I've got a minus and a plus, it will mean that I would be adding the equations to eliminate. So basically looking for the lowest common multiple between 3 and 5, and that would be 15. So I want to be making both of those numbers into 15. So I'm going to times that first equation by 5, and I'm going to times the second one by 3 in order to do that. So that does mean that my equation becomes 20a. So I'm timesing everything in this first equation by 5, so I get minus 15b, and I get 35. So I'm now going to call, because I've changed that, I'm now going to call that equation 3. Then I'm going to times everything by 3, so I get 9a plus 15b, and equals minus 6, and I'm going to call that equation 4. Now notice that the numbers in front of the b term are now the same, so that does mean I can eliminate, and because these are plus and minus signs, I'm going to be able to add. So I'm writing in here at the side what I'm doing, so I'm adding equation 3 plus equation 4. So you add your a terms, that's going to give you 29a, and they cancel out, and we get 35 add negative 6, and that is of course 29. So we end up with dividing by 29 would give you a would be equal to 1. You still have to work out your b value, and you can do that by subbing a into either equation 1 or 2. I'm going to sub a equals 1 in equation 2 because it's all positives on the left there. So I get 3 times 1 add 5b equals negative 2. So that's going to give me 3 plus 5b equals negative 2. I'm going to subtract the 3, and that would mean I get 5b equals minus 2, add minus 3, that's all together negative 5. And if I then divide each side by 5, I get that b is equal to minus 1. So your solution there is your 2 values, put them together, you get a equals positive 1 and b equals minus 1. Now your marks in this question, you get a mark for correctly scaling your equation. So this line here where we've multiplied is really like that's the first mark. The second mark is for the first value of your A or your B if you'd worked it out first instead. And the third mark is really for the final value that falls through to get your B value. Right, question 5, this is a vectors question. You just need to be able to remember how to work out the vector. These little parallel lines mean the magnitude. So the rule to work out the magnitude of a vector is that you square, it's a bit like doing Pythagoras, square and at the same time you're doing take the square root. Now you weren't allowed to use the calculator here, but you should still put brackets around the -3 squared. Right, plus the 2 squared. So, no calculator, 6 squared means 6 times 6, which is 36. -3 squared is -3 times -3. Two negatives multiply, always give you a positive, so that is +9. And then 2 squared is 4. So if we add all that together, we get 49. And the square root of 49 is one that you would be expected to know, and it has the value of 7. So your marks here are 1 for your method, and then working out your answer, correct answer, get you the marks of 2. This last question is a change the subject, and you're trying to get to m equals. So first of all, we can see we've got a square root involved in this. So I'm going to switch my sides and I'm going to write my m/5 on this side equals L. And it's the m term I'm trying to isolate, but to get rid of, because that square root sign is covering the whole fraction, I'm going to say the opposite of a square root is to square each side of this equation. And when you square each side of the equation, it means the square root sign disappears, so you just get m/5, but this side you would get equals L squared. And then to get to the m on its own, right, you would need to, this is you dividing by 5, so to get rid of a dividing by 5, you would be multiplying by 5, and you would do that on each side. So on this side, of course, when I multiply by the 5s will cancel, and then my final answer is therefore m equals 5L squared. So how you get the marks here, you get for squaring each side and writing down that statement there, that's the first mark, and the second mark is for doing that multiplying by 5 and getting to the final answer. So check through your working that you did that's been marked and look for ways of giving yourself feedback. See if you didn't know how to do a question, have a look at it and check that if it comes up again, if you asked to do a similar question, that you'll be more confident with tackling that question the next time.